Hello and welcome. Today I'll be solving this question of powered addition. This is Codeforces problem C if you consider it division 2, and it's a problem A if you consider it division 1. Okay, so let's get started. I'll just read quickly and you can also have a look. Okay, we are given an array of length n. For every positive integer x, you have to perform the following operation during the xth second. Okay, you have to select some distinct indices which are between 1 to n inclusive and add to the power x minus 1 to each corresponding position of a. Okay, so when x equal to 1 we'll add to the power 0, then 2 to the power of 1, which means we have to add numbers which are the powers of 2 to some selected indices of array in each operation. Okay, so in each operation we have to add some powers of 2 to selected numbers, and finally what we want, make a non-decreasing as fast as possible. So we have to make a non-decreasing, which means this thing a1 is less than equal to a2, like this. Either it will be increasing, strictly increasing, or it might be equal. So a1 might be equal to a2, or a1 is greater than a2. Sorry, opposite. a2 is greater than a1. Okay, so how can we solve this one? Let's start with few examples. Okay, so here is our first example. When the array is sorted, so we need not do anything because this property is already followed. For all I, ai is greater than equal to ai minus 1. Let's take some other example. Let's say this one. So here we have the array which is descendingly sorted, or you might take some other example as well, but this example would be very good, so I have taken this. What we have to do is, here is the index. So what is our ultimate goal? Our ultimate goal is to have an array A in which this property is to be followed, right? Okay, so how can we achieve this? So we can clearly understand from here that this 1 has to be the maximum element in the array, right, for this property to be followed. So ultimately we need some value at this 4th position, which is the maximum in the array, right? Because we at the end we want a sorted array. So how can we do this one? Clearly we have to add something to this value. So let's think in this way. We will compute maximum array. Okay, so we'll compute max for all positions in this array. We'll iterate through the array and we'll calculate the max. So when I'm at position 0, then I have only one value, which is 5, and max is 5. Now I go to next position and I compare between 5 and 4, and my max is 5. Like this, my max is also 5 here, and we have 5 here, and we have 5 here. Okay, so we have our max calculated. Now we have to check the diff. I think this case better if I put it here. Yeah, okay. and this is a little below. Okay, so now we have our max calculated. Okay, so for 5 this is max, 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 max. Okay, so if we observe this, then we can understand clearly that at any point of time we have this element should be greater than this one, or it should be either at least equal to this one. This element should be greater than equal to this one. This element should be greater than equal to this one. This element should be greater than equal to this one. Or we can also say that when we are at this position, if we of this one of 4, let's say we are at position 4. Okay, so at position 4 we see that the element is 1, but we also have seen that the max is 5. So this element should be at least greater than equal to 5 for the property to be followed, this property. Okay, so this element should be at least greater than equal to 5. This element should be at least greater than equal to 5. No, sorry, it's not true for this one, it's only true for this one, because there is a last element in the array, and last element is a maximum element. Okay, so whenever we are calculating this array, suppose we are at this position, then it will be true here that till now, max till now, we can call it max till now. Okay, yeah, so we will check the value of max till now, and we'll see that this element should be greater than equal to max till now. Okay, so we'll compute another value of ai minus, or the opposite one, I would say, yeah, this one. So for every I we have to find this one. I hope this is clear. For all I we have to find max till now, and then we have to obviously we have to check if max till now is greater than equal to ai. Okay, so we'll calculate this one, and we have to add that much amount. So here the value is 4 of ai, then max till now we see that it is 5, so 4 should be till this. If we consider that the array consists only of 2 elements, then till this position 4 should be the maximum element. Okay, so 4 is clearly not the maximum element because 5 is the maximum element, so we have to increase 4. So how much? By max till now minus ai, this much amount we have to increase this current I value. Now we have to see in that problem that for each test case print the minimum number of seconds in which you can make a non-decreasing. So to make a non-decreasing we have to do this one, right? For all elements we have to follow this thing. Now minimum number of operation, so how do we find that? We'll see what is the maximum of this. So we know that at max this many operations are needed. Okay, so if this many operations are needed at max, then suppose not this many operation, but this is the difference actually. Okay, so this is the difference. Okay, so we'll find the maximum difference, and we'll just find the, since we are increasing in powers of 2, let's say we are saying this as max difference is equal to this. So our answer will be nothing but log base 2 of maximum difference, right? This is our answer. Because since we are increasing, so this is the maximum difference that we have to cover, and log base 2 of this one, because we are at a one operation we are increasing by powers of 2, so this many operations are needed to cover a maximum value, which is the maximum difference. So at max we need this many operations. Okay, so I also have code written for this, and I have got it accepted. Okay, so what I'm doing is I'm initializing maximum to a lowest value, and required is this 0. So maximum difference, I'm telling it as required okay. So I'm just looping through the array. I'm calculating the max at all positions. When I'm here, max is 5. When I'm here, till now max is 5. Till now max is 5, like this. And at all positions I'm also calculating required. So I'm directly calculating maximum value of max minus I. So what if this value is negative? Nothing will happen, because it will not be updated in required, because required current value is 0, and if this is negative, required will take this value. So required value is always greater than equal to 0. And when I come out of the array, I have this thing with me, which is the maximum value, which is the required maximum value. Now instead of doing log, I've just iterated it. So 1 ll means we are increasing the answer by powers of 2. So this is just bitwise left shift, which I have done. So initially I have taken answer as 0, so I'll take to the power 0 is less than equal to required, then answer plus plus, and so on. For each increasing, I am calculating, for each increase of answer I am calculating that power of 2. So initially it's 0 and it will increase, and hence we'll find the answer. Okay, thank you guys. I think I'm done with this one. If you have any problems, or you have any doubt or confusion, you can comment in the comment section below. I'll be more than happy to help. Thank you.